This is a LEGO Minifig lightsaber, and this is a 10x scale LEGO Minifig lightsaber with sounds and lights. Keep watching to find out how I made it. So in the base of my lightsaber there's a little speaker and a USB charging port, and there's a little button on the side here which I press to turn the lightsaber on, and press again and hold it to turn the lightsaber off. I can also change colour. During power off, if I press it again, it will cycle through all the available colours. There's yellow, green, blue, purple, white and red. So I can press it once I get to the colour I want. Let's try green. Now I have a green lightsaber. The handle of the lightsaber is 3D printed in several parts. We'll take a closer look at that later. And the top is made from an acrylic tube. Inside the tube there's some NeoPixel strip, and in the handle there's a battery and all the electronics required for the sound and the lights. So the first thing to do to take a look inside of this is to take the acrylic tube off. And the NeoPixel should slide out like so. And now to take this a bit further, I've got to disconnect this connector here, and I've got to take some screws out the bottom. So to do that, I'm going to do it on the bench so we can take a look at what's inside. So one of the first things I need to do is disconnect the top electronics from the bottom electronics, and there's a little connector in here. Okay, so there's the Pico blade connector. Next I'm going to take out the screws on the bottom so I can take the speaker cover off. And now we can see inside. The speaker comes with double-sided tape on it, so that's nice and handy for mounting. So what I need to do now is actually pull some of these electronics out. There we go. So you can see the battery connector here. So I'm just going to disconnect that first. Now I'm going to try and remove the Arduino Trinket M0. There it is. It comes out of that little slot here. And gently pull, and the battery comes out. And there's that Pico blade connector that was going up into the top here. So there's the little electronics assembly. We've got the Adafruit Trinket M0 here, the Trinket backpack, which is for charging the LiPo battery. And there's the 2.5 watt audio amplifier and a 1 watt speaker. These are all Adafruit parts, and I'll put a parts list together at some point. It is easier to show how this is wired up through the Fritzing wiring diagram, so let's take a look at that. Let's start with the battery, which is plugged into this Adafruit Trinket LiPo backpack. This is used for charging the LiPo battery from the Trinket M0 USB socket. The connections for the charger are red and black for the battery power, which goes to the amplifier board, the Trinket M0 board, and to the Pico blade flying lead, which is plugged into the top end electronics. We also have the orange USB power line, which comes from the M0 to charge the battery when USB is plugged in. On the Trinket, the yellow wire pin 1 is the DAC, digital to analog converter output for audio, and the green wire pin 0 is used for shutdown output. This controls power to the amplifier and the NeoPixel LEDs. The blue wire pin 4 is the NeoPixel data pin, and pin 3, the purple wire, is our switch input to turn the Saber on and off. The top end electronics is connected by a 5-pin Pico blade flying lead. The red battery power go into the NeoPixel strip positive, the black ground wire goes to one end of the switch and to the N channel FET source pin. The purple wire is the switch input to the Trinket, the blue wire is the NeoPixel data line from the Trinket. The negative power rail on the NeoPixel is connected to the FET drain pin. The green shutdown wire from the Trinket is connected to the FET gate pin via a 330 ohm resistor. There's a note here about what I'm using for the FET switch circuit. This is needed to disable power to the NeoPixels when in standby mode to maximise battery life. I've got my system down to about 400 microamps standby, but to do this I had to remove the dot star LED on the Trinket and the green power LED. It's not easy removing these components, so don't feel you need to. The device will draw a bit more standby current of about 2.5 milliamps, but still give plenty of standby time. However, the FET switch for the NeoPixels is essential for a reasonable battery standby time. Getting this part out at the top is a little tricky, because what you have to do is take this button off of the switch, which means levering it off. It's just a push fit, and then undo the nut that's on the switch in there. So rather than do that on this one, I'm just going to pull in another one in true Blue Peter style that I made earlier. So this one's halfway through being finished, and you can see there's the Pico blade connector there, the male socket one, and there's my little FET transistor on there, which is switching the NeoPixels on and off. There's one component missing, which is the 330 ohm resistor, which is why there is a wire currently not connected. So I've got to finish that off. And so that all goes together into the top of one of these 3D printed parts. The switch slides down inside and pokes through this hole here, and then the nut goes on the back of the switch, and that basically then becomes one. So what I've done with the NeoPixel strip here, it's 84 pixels, 42 pixels on each side, and it's just folded over the top and then run down the other side with a piece of insulation between, and obviously this quite thin heat shrink to hold it all together. Then what I do when this FET is finished, I'll fold that up like this and put another piece of heat shrink on here just to hold all of this together nicely. And then I've also printed these little parts, which are printed in clear PETG material. So 4 of these little spacers get fed on here. And what that does is just keep that NeoPixel strip in the middle of the acrylic tubing. And you can see those spacers there, keeping the NeoPixel strip somewhere in the middle. This is a 32mm acrylic tube with 2mm wall, so a 28mm internal diameter, and it's a 300mm length, which you can buy online. Working off that inside diameter, I've cut a strip of A4 paper down to 87mm across. I also have a cap that I've printed, also in translucent PETG, which goes on the end. In order to get the diffuser in place, just roll it up into a smaller diameter to the inside of the tube and then slide it inside, let it expand. Now I did try a version which wrapped around twice, but I found that it diffused, it took a bit too much of the brightness out. But what you do want to try and do is get rid of that gap there. You don't really want the paper having a gap in it, because that will show. Anyway, play around with it until you get it just right. And then of course the cap goes on the end, which can be glued in place. And then I just slide the paper up to touch the edge of the cap. The NeoPixel strip just goes down inside of the diffuser like this. I've actually cut this diffuser a little bit short. I should have left it a bit longer. That all goes up inside once it's assembled. Here are the 3D printed components for the hilt of the lightsaber. Now, of course, if you watch my channel, you'll know I don't like printing with anything with support material, so that's why this is broken down into so many pieces. But there should be a hole through the top. You can see the outline of it in there. So I have to cut that out first of all, so let's just do that. And that's for the cable exit for the Pico blade, the 5-way Pico blade connector that comes up from the main body. I did originally have this joined with 2 screws that went down into the main hilt here, which had some captive nuts, but I've decided that's not actually needed. You can actually just glue this part together. This is the cable recess there in the tube, so if I grab the battery, you can see that that's where the cables run, and that needs to be lined up with that hole when it's glued together. But before that happens, these go on, and on this part you'll see there's some ridges, and they are there to set the position of these 2 parts. So I can put one on from the top and one on from the bottom. So that's ready now to have that glued on top, which should be something like that. Now the bottom part here Again, this is a glue-on part. The only part that then ends up being screwed on is the speaker on the bottom here. And that's so that we can get this off and take all the electronics out after assembly. The screws that hold this onto the bottom are M2.5 by 10 or M2.5 by 12 millimeters, like this one here. And there is a M2.5 square captive nut held down in either side of this part, just in there. Again, there's some alignment here, so we have to get these two recesses lined up when this goes on. Sorry, this way around. And we can check that they're lined up by putting the trinket into position like that. So that's pretty good line up. So that now needs gluing in place. I'm going to attach the speaker. So I'm just going to push my M2.5 screws down into these recesses on the base of the handle, like that. So that's ready to line up on top of here. Our speaker gets tucked down inside and popped into there. That's going to keep us lined up. Okay, let's take the protective film off with our grill the right way around. Hopefully it will come out with the speaker attached. Just make sure it's pushed down nice and firm, and that's the speaker fixed. Just remembered that I needed to add this resistor and put the finer wire on my little FET switchboard here. Here's my slightly updated version of the electronics. It's virtually the same, I guess, maybe a little bit neater. I stuck with a flying lead for the battery, although the little USB charger does come with a connector on it, so you can plug the battery straight in. But I just added the little 2-pin Pico blade connector for the speaker, so the speaker can be disconnected. Let's do our final assembly. We have our Pico blade connector, and we have our speaker and the battery. So when the system boots up, it goes through this sequence, which was part of my debug code, and it'll count all the way down and then go to sleep, but I can skip that by pressing the button. Okay, that's good, that's working. So now theoretically, we should be able to power up. There we go. In green mode, so let's power down and test the program in. Let's stay on red. Probably a good time now to take a little look at the code. I've got googly eyes. So after 50 years of staring at computer screens, my eyes have finally started to give up. I've got glasses now. If I do that, I've got googly eyes. I'm using the Adafruit NeoPixel library. I'm not using the DMA version, which you can use for the M0 processor, because you can't shut down the digital output pin as well as you can with the standard library. And that saves a huge amount of power, because you get leakage down the data pin on the NeoPixel strips even when the power's turned off, because the positive line is still connected. Anyway, trust me, this is better. The only downside of not using the DMA library is you get distortion on the audio output, but actually it's quite nice. It adds a little bit of crackle to the audio, so I've kept that. So I've got various compile options down here, the pin setup. My audio player section here, I'm using the library I found online. Where is it? Audio player, there we go, which outputs 16 kilohertz mono 8-bit samples, which you use this link here to convert them into header files, and you get this little array there, which is quite nice. So they're built into the flash storage on the Arduino M0. I've got my variables here for my NeoPixel strip, the dot star that's built onto the M0 Trinket, and my variables and functions. I'm using a flash storage routine that I found online as well, and that is because there's no EEPROM on the M0. Pretty standard setup. Just set the pins up, initialize the serial port, bit of debug, initialize the NeoPixel library and the dot star library, send some information to the serial port, then initialize the DAC output for the audio. So rather than using the signed functions, I'm generating my own sine table for speed when I'm using it in my pulsing the lightsaber. This just turns off all of the bits like the NeoPixels and the audio amplifier and what have you. Then in the main loop here, the first thing we do is put the lightsaber to sleep, so that actually puts the M0 processor down into its low power mode. There's two ways you could do it. You could sleep and wait for a timeout to happen and then check the button, or you could attach an interrupt, so when the button's pressed it wakes up immediately, which is the more efficient way to do it. It says, are we awake? Yes, so it powers up the saber, and we literally sit in this routine waiting for the saber to be powered down. So this loop runs 50 Hertz, so 50 times a second. We're looking at the keyboard, we're looking at, we pulse the lightsaber and we show update the LED strip. There's a little system tick here that runs every quarter of a second, and that is to check for the power down button and also to send a little debug message out so we know that we're still running. If it does get the power down press, then it powers down the lightsaber here, comes out of this loop and goes back up to the top and puts the lightsaber back to sleep again. The pulse saber routine is rather convoluted, but effectively what it's doing is putting a sine wave through the lightsaber pixels. It's modulating that sine wave with some random noise and the amplitude and stuff to get that effect. And I just played around with the values until I got something that I thought looked quite good. So the power up saber routine here, it enables the NeoPixel strip and the audio amplifier. It plays the first sample, which is the power up sound. It runs in this loop here, which is basically to increment the LEDs as it goes up and also pulse them at the same time. So I did have to modify the audio library to add a loop sample function. The power down routine is pretty much the opposite. It plays the power off sample and it sits in this loop whilst the LEDs slowly count down. It checks to see if the user has pressed the button during that power down cycle and goes into program mode. If it's not in program mode, then it literally just shuts everything down, and that's where it will go back to the top of the loop and put the processor back to sleep. In program mode, if that's enabled, then effectively it starts cycling through all the different lightsaber colors, and once the button's pressed again, it saves that color in flash storage and then goes back to sleep again. And there's my sine lookup table routine, which is faster than using the intrinsic sine functions. Finally, this is the check keys routine, which just looks for keys being pressed on the terminal so that you can adjust the amplitude and the frequency of the pulsing of the lightsaber. It's pretty clunky at the moment, so it would be nice to have a proper user interface for that, where you could have sliders and stuff to adjust the color and the frequency and play around with the effect you want. Maybe that'll be version 2. Right, let's finally put this together. I'm going to disconnect the battery again and disconnect that. I need to remember to put these nuts down inside of here. They sit inside that little chamber, and then I'm just going to use a soldering iron to seal them in. Now, the tricky part. So I'm going to put the electronics down inside so that the cable comes out the top. The cable really wants to sit down the bottom like that. Like so, and hopefully we've still got our cable showing at the top. Put our trinket into place. The trinket's down into its little pocket there. Now I'm just going to push this back down inside, connect the power. I'm just going to check it before I go any further by attaching the top end. Okay, that seems all right. Let's just test the sound. That's good. Now we just need to get all of this into here. These switches come with a little tiny nut. I'm just going to wind one of these off. They come with 2. So now the switch is in place. What you need to do is drop the nut onto it and use a screwdriver or a tiny nut spinner if you have one. This is not the right tool either, but it kind of works. The flat edge of the screwdriver. So I might just make that button a little more proud And maybe a little bit smaller. It's a little bit tight in there. You can just make out that seam where the paper's overlapped there, which is kind of annoying. You might not see it on camera, but I'm sure I could do better with that. Hey, light side and the dark side. Yeah, I think I need to work on my form or my flow. What's it called? No doubt lots of people will want to tell me, but that's pretty cool. They make a nice sound. You can probably pick that up in my microphone. The only thing I couldn't really fit into them was a sensor to pick up movement, which I'd quite like to do at some point. I think I could probably just about squeeze one in somewhere, or I could make them slightly bigger. I'm genuinely really pleased with how these have turned out, and I should just point out they're not really made for battling. This is acrylic tube, not polycarbonate, and they're probably not quite strong enough yet, especially as the fact that this just slips out. I mean, it could be glued in, but I don't want to glue them just yet. They really are made for decorative items. Being a decorative item, I was thinking about how to display them. So I printed up one of these, a 10x scale Lego hand, which of course clips onto the lightsaber. And then I thought, well, what can I hold on to this with? So I did that, which I know is complete illegal Lego, but it makes a really nice little stand that you can put on your desktop. Or maybe you can mount it on a wall like that. Anyway, I think it's quite a nice idea. Maybe I should have done the entire arm, I don't know. Let me know what your thoughts. How would you display one if you had one? I've obviously talked a lot about trying to keep this in low power because I want it to last plenty of time in standby. So I've done a few calculations to work out what that approximately should be. So if you do the modifications to the Trinket like I did, you remove the dot star LED and the power LED, you can get the standby current down to about 400 microamps. And what that means is it'll have a standby time of about 200 to 250 days, which is plenty. Now, if you don't do those modifications, you're still looking at about 30 to 40 days of standby, which is still enough. As far as runtime is concerned, you're looking at about 1 to 2 hours, I think. It may be longer, I'm not sure, I just have to try that out. The charge time for the Saber should be about 4 to 5 hours. A couple of features I might add to the software is to have a mute mode that's programmable, so that I could have like this one in the background lit up but without making the noise, and also maybe a lower power LED version so that you can just have it as a decorative item without draining the battery too fast. I've had quite a lot of people asking what's happening with the giant Lego car chassis project I started last year. Well, I'm still printing parts for it. I'm about 97% done, so hopefully that's not going to take too much longer. Holy! Well, that's it for now. I hope you've enjoyed this episode, and don't forget to like, share and subscribe. I'm off to practice my form. Bye!